I've been reading a book that's called Ignition. I just finished it like a couple of days ago. Way before that book, I had learned about rocket engines and how they work and stuff. On the stuff, very basic stuff that you can see on the web, um, one of the most important things, or one of the most common things out there about engines, from rocket engines, is that to measure rocket efficiency, you use something called ISP. ISP, it's specific impulse. I need some measure of how efficiently a rocket engine can burn its propellant. Now, it is measured in seconds, so basically what it means, here's the equation. If you want to see, you just need to look for specific impulse. Now, it is measured in seconds, so basically what it measures is, given a certain amount of propellant and given in an ideal scenario an equal amount of weight of propellant, of mass of propellant, how long can this engine produce thrust in seconds? So higher means better because it means it burns for longer, so you have more time with a specific amount of thrust. Now that's all and good because it is actually pretty useful. But what had been bothering me for a while is that everything on the web kind of ignores what makes a propellant have a higher ISP than a lower one. They talk about ISPs and this engine being a little bit better and this engine being a little bit better, and then they kind of talk about efficiencies and stuff like that, but they don't really explain why is the reason that certain propellants, certain engines, why they have a higher ISP. That's kind of intuitive to know. It's just if an engine is better, it is gonna have a higher ISP. But a propellant, it is a little bit weird because one of the things they talk about but they don't really explain, which bother me, which is why I'm here, it's light molecules and light atoms produce a higher ISP for a given engine than a heavier molecule. Now, at the beginning when I learned this, I just used two brain cells and I quickly became confused because what I thought was this: well, if you have propellant A and propellant B and you shoot that through the nozzle, it shouldn't matter if one is heavier but slower and the other one is lighter but faster, because it should equal out. Like if you're shooting from the back of the engine something heavier, well, then it is going to be more it's going to produce more thrust, but as long as it's at the same speed. But if it's not at the same speed and one is faster than the other, then one being heavier than the other one should equal out. But this is not actually what happens on real life, on real engines. On real engines, broadly speaking, when the exhaust gases are lighter molecules or lighter atoms, the engine is more efficient. And it took me a while to answer this because there really is not there is the knowledge of why it happens, but there is some studying still going on how to measure this and how exactly it happens. Or even if there's no research ongoing on this, everything seems kind of not popular. So it is a little bit hard to find out, as far as I could tell. So the answer to this, it's because if you see again on the ISP formula, one of the factors for the ISP formula right here, it's exhaust velocity. Now, that makes sense, you know, the exhaust velocity of the propellant of the gases, you know, just multiply that by the area of how much gases you're throwing at the back and you get thrust. But calculating exhaust velocity is kind of hard because you could have different gases, or you could have different temperatures, or many other reasons. And that is the thing, that is the answer. That took me a while to figure it out. But the simple answer is this. Most small atoms, like hydrogen, helium, lithium, all of those, not exactly, but generally speaking, they have a quality that's called specific heat ratio that is higher than other things. Now, what does this mean? It actually is pretty simple, and once you understand it, you understand why these atoms are better than the heavier ones. An atom, if you think of it as a single thing, it moves and vibrates, and that, it's the temperature, it's the heat that the atom has. Different atoms, you know, there's different sizes in atoms, and they have different nuclei and stuff. Different atoms and different molecules, so it can be a diatomic gas like nitrogen, or oxygen. Different atoms have different capabilities to absorb heat and move around. So a solid has almost, well, not almost, it has less capability of absorbing heat than a gas, because a gas moves around everywhere, and a solid, it has his bodies right next to each other. So the only capability of that atom to absorb heat is by vibrating. Sometimes the entire compound can move, rotate on several directions. But gases are way better. Like, gases can do the same thing, can rotate, can vibrate, can stretch the bonds. It has to be symmetrical though. And most importantly, gases, if you have a gas, the gas molecules are really small, and they are moving around, and they bounce from each other, and they're really far apart from each other. So light gases have a really good capacity to, when you apply them temperature, they're gonna expand. And that is the simple answer to why lighter compounds and lighter gases make a higher ISP. And it's that simple fact. For a given amount of heat that your combustion, so if this is the combustion chamber, inside you're gonna put in the propellants, and then they're gonna fire, and you have a combustion chamber. The combustion chamber has a limited capability of producing heat, which is dependent on the temperature that the propellant can reach, and the temperatures and pressures that your engine actually can handle. So if you have a material in here that it is very good at transforming the limited heat that you have into expansion force, which is going to be kinetic energy, the better, or the more the faster the exhaust velocity is going to be. And that is why, and that's pretty much the answer. So yeah, that's pretty interesting.